Start out today with a little thing called the old location principle. Difficult to read math, pretty easy to understand if someone can translate it for you. Says suppose y equals f of x, so whatever, y f of x, same thing. You got a polynomial function, and a and b are two real numbers such that the function evaluated at a is less than 0, and the function evaluated at b is greater than 0. Then the function has at least one real 0 between a and b. My job is to take this and translate it to you. Okay? So here's a polynomial function right here. They say a and b, they're just like x values, if you will, right here. And if you did the function evaluated at a, isn't that really saying like the y value? When you put a in for x, it's like what would y turn out to be? Here's the function evaluated at a, right there. They're saying if that's less than 0. Doesn't that mean that that would be negative? Correct? Isn't this a negative y value right here? Right? So you've got basically in your own language that you can understand, x negative y. Cool? If you've got another point b, but the function evaluated at b is positive, right? So you've got another x, so let's call that x2 and call this x1, but y is positive, correct? They say somewhere between point A and point B, there's got to be a 0 on there. This thing has to cross the x-axis somehow. If you've got an a right here and a b right here, and in between the y value was negative to positive, that thing had to somewhere cross the x-axis. There has to be a 0 involved because y went from a negative number to a positive number. So somewhere in between there's got to be a 0. Sound odd. It'll make more sense here a little bit. Well, let's talk about some basic vocab right here. A relative maximum. A relative maximum is someplace on the graph where you kind of see like a maximum, but it's not the absolute maximum of a graph. For example, if you have a little graph like this, parabola that opens down, see this point right here? Isn't that the absolute maximum of that particular graph? That's as high as that thing will ever get, right? That's called an absolute maximum. A relative maximum is something like this, to where the actual polynomial itself, it changed from, do you see my pen right here? Isn't the graph like going up right there, or as we say, increasing? And then all of a sudden it changed to go decreasing. Doesn't that look like some sort of max out point right there? But it's not the absolute max of this graph, because doesn't that graph go up forever and ever and ever? It's not an absolute maximum. It's just a place where the graph changes from increasing to decreasing. It's called a relative maximum. And likewise, a relative minimum is a place where the graph changes from decreasing to increasing. It is like a minimum guy, but it is not the absolute minimum of it because that graph continues to go down and down and down and down. Does that make any sense to you? Those are called extrema of a graph right there. If they say, please find all extrema, they're saying find the relative maxes, find the relative minimums, and all that stuff. Please find all the extrema. And these places are called turning points also. It's where the graph turns around. It's a turning point. All the extrema is a turning point. And the fact of the matter is, if a polynomial function has degree n, then it could have at most n minus 1 turning points. So if I had this graph, f of x equals x cubed, what is the degree of that thing right there? That's got degree 3. According to this, the most amount of turning points that this thing could have then is whatever that degree is, take away 1. So how many turning points maximum could it have? 2 maximum, right? It doesn't have to have 2, but that's the maximum amount it would have of turning points. Cool? So here we go. Example 1, zeros and maximum and minimum points. Consider this particular graph right here. We can do pretty much all of this except for the last thing without our graphing calculator. It says find the zeros, find the relative max, relative min occur, analyze the table to help you find some of these points, and also graph the function on your calculator to trace these features, blah, 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 blah. Right? First thing I want to see is let's use this in action, the location principle, to realize where there's going to be some zeros just based on the table alone. Pretend, oh pretend for me that you can't even see a graph yet, right? No graph there. Can we figure out where there'd be some zeros for sure? Well, you look at the table and you look at the y values, aka the f of x values, and see where they go from changing of signs, either negative to positive or positive to negative. Doesn't that happen right here? Isn't the y value a negative 3 and then doesn't it change to a positive 22, correct? That means that there has to be a 0 between negative 6 and negative 5. So let's put that. Must be a 0 between negative 6 and negative 5. There must be a 0 between negative 6 and negative 5. And if you look at our graph, right, x is negative 6. Well, this is negative 2, negative 4, negative 6 right here, and here's negative 5 right there. Does that thing cross the x-axis between there somewhere? Awesome. See if you can find me another one based off the table alone. Don't look at the graph. Where do the signs change in the y value? All of a sudden it went from either positive to negative or negative to positive. Where you got? From negative 1 to 0, right here. Doesn't this go, it's positive, 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 oop, went to negative, correct? Didn't it change from positive to negative? So there must be a 0 between what? Between negative 1 and 0. There must be a 0 between negative 1 and 0, and we see that right here. Here's negative 1, here's 0. There's a 0 between there. And also, it goes from negative to positive again. Don't you get another 0 right there, right? So 0 between where and where? 0 and 1. Does that make sense to you? Like, if you only had a table of values, you could at least estimate where the zeros are based on that, right? Because the signs change. They ask us to now use this and tell us where a relative max is at. Let me put some points here just for multiple choice. A, B, C, D, E, and that's it. I got A, B, C, and D, and E in this picture. Where do you feel there's a relative maximum at? Choice B, right? Some place where it like maxes out, but it's not necessarily the absolute max. Where is that bad boy at? Well, do you know the x value? Negative 4. Look in the chart. Can you figure out what the y value is? It's negative 429. Find the relative minimum, if there are any, with your pal. Then. Use the graph, use the chart to help you. Where do we feel it's at? A, B, C, D, E, any of them? D, and what's the x value of that puppy? 0. Look to the chart. Boom, 0 what? Negative 3. Now, the zeros, right? Where are these guys at? We have already used the table to guesstimate where they're at, correct? We will now use our graphing calculator to figure out where they are at. So let's take this function right here, and let's put her in our graphing calculator. And I'll show you a trick after this. Let's graph it. You want to zoom 6 it, or what do you want to do? What window do you want? Zoom 6? Okay. Oh, crap. My bad. AX. Zoom 6. Shouldn't it be the same thing as this right here? Would you all, I mean, that's the thing. How come I don't see the top, like that relative max? How come I don't see it? Window's not big enough. Doesn't this thing go up to like 29 or whatever we figured it at? And this only goes up to 10. But we don't care about that, because what are we trying to find on this puppy? Just the zeros, correct? So here's how we did it in the past. We will do second, calculate. And which one of those do we want? Zeros. That's choice 2, correct? So then you have to do above and below, left and right. So let me get my little cursor. Let's all find the far one on the left. If I can get my cursor there. Doesn't this really suck to like find your cursor and get her over there? It's like I can't even see my cursor because that thing goes way off the graph and everything. It's like, where's my cursor at? I can't even find it. That's why I was complaining this is so difficult. But here's what we did before. Do you know where it should be? Between what and what? It better be between negative 6 and negative 5, right? So I got my thing below it, real to the left, so I'll hit enter. Then I want to go to the right of it, and it jumped way up there already. And then it makes me to guess. I just hit enter one more time. It'll find it for me. And they say round it to the nearest tenth. What do we got if we round that to the nearest tenth? Where's our 0 at? We'll just put the x value, right? So about negative 5.9. Is that okay with you? And I'll do one more the hard way, and then I'll show you the last one the easy way. Right? Let's find this other 0 right here. So let's second calculate 0. Move that cursor way over there. La, 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 la. Can't even see it. It's off my thing. Please show up soon. Come on, buddy. There you are. Hey, guy. How are you? Been a while. Got to be above it. Got to be below it. Round to the nearest tenth. About what? Negative 0.8. Right? About negative 0.8. But the hard part about that is the fact that the cursor was disappearing and reappearing and disappearing. Then you got to go above and below and guess, right? Here's the easy way. Let's go back to y equals. There's the function that we want. Cool. The other thing we want to know is the zeros. Well, in the zeros, what's the y value every time? Like here's this point. What's the y value in all those ordered pairs? I want to know when y equals 0, so why don't I put that as my second equation right there? Doesn't this just say y should equal 0, right? Now if I go back to my graph, instead of doing the zeros, you don't even see it graphed. Like it graphed both lines, I should say both polynomials in there, correct? But you don't see y equals 0 because isn't it the x-axis right there, correct? All I want to know is where those two things intersect each other at, correct? So all I have to do now, instead of hitting second, calculate, and go into 0, which option do I want instead? Intersect, which is choice 5. And what makes that so easy? Because you don't have to move that cursor very far at all. They just want to know, what's the first guy you want? Well, it's going to be this one. I just hit enter. What's the second one? I just hit enter, because there's only 2 in there. Now I got to guess, but look how easy it is to move your cursor, because it's on the x-axis the whole time. It's on the line y equals 0. I'm just going to guess, move my thing closer to that guy, and hit enter, and they intersect at that point. Isn't that the 0 in the first place when y equals 0? So to find the zeros, it is way easier, instead of using the choice 2 in the menu, is to graph the line y equals 0 and find where those guys intersect each other at. It's much easier, and that's at about 0.7. Rock and roll? So let's do that on the back side. They ask us to graph this function on our calculator and make a simple sketch. We need some straight edges here. Let me get those for you in a second. You don't want to just make a straight up normal axis because we don't know what this graph is going to look like. You know, we got to figure out a right window first before we make our x and y axis, because sometimes the x-axis will be way down here, sometimes it'll be way up there. So we want to graph it first to see what it looks like and find the right window. Let's punch this puppy in. So we'll go back to y equals. And I'll clear the top guy out. You can leave the y equals 0 in the second guy. Just type her in. Negative x to the 4th plus 2x squared minus 1. I got a question, though. Can you tell me where the ends are going? Same way or different ways? They're going the same ways, right, because it's even. And where are they going, up or down? They're going down, okay? Let's zoom 6 him, see what he looks like. Do we see it all? Answer, yes. Not a good window, though, because it's not really zoomed in enough. Nothing going on up here. Would you be cool with that? Too much space over here, so let's change our window. What do you want the x window to go to? You can see, let's do that, from negative 5 to 5 on the x-axis. The y minimum still looked pretty good to me, but the y maximum, can't we just put him to like 2 or something like that, since there was nothing above the x-axis? Now here, graph, and let's see what that looks like. That looks much better to me. Cool? So let's take our straight edge, and let's make ourselves some axes. You can fill up this whole little spot. There's not much going on besides our rough sketch here. Cool? And what we'll do before we try to sketch the actual curve is we'll find all of the things they're asking us to find. All the relative minimum, relative maximum, and the zeros. They're saying, please find all the relative extrema, right? That's relative mins, relative max, and the zeros. Cool? First thing I'm going to find is a 0. Do you see this guy right here? If you was to take a wild guess, where would you guess that that point is on this puppy? -1, right? Here's an easy way to check to see if that's a 0. If you just hit the trace button, right, not second trace, but just trace, you hit trace and then hit -1, it automatically asks you, like, oh, you want me to figure out what x of -1 is? If you hit equals, it will take you to that point. And what did y turn out to be? 0. I just proved to myself that that was a 0. I had a rough idea that that's a 0 right there. It looked like it, but the only way to prove it is to figure out if x was -1, would y turn out to be 0? Yes, it did. Yes. So I'm going to put that on my grid right here, right there, -1, 0, as an ordered pair. And I'm going to label what that is. Is that a 0, yes or no? Is that where this thing crosses the x-axis at? So we'll call him a 0. And do you see where on your actual graphing calculator, isn't the graph itself like kind of below that? Let's put that information above it then so it doesn't get in the way. Here's the other question. Is that point also a relative maximum, yes or no? Is that kind of like a relative max? So it's a 2-for-1 special. It's a relative max, which we'll abbreviate rel max, comma, it's a 0. They're just asking us to label these points on the graph. Sketch, well, we found that point. It's a 0, and it is also a relative max. Take a wild guess. Do you think that that's a 0 right there at 1? Let's double check. Hit trace 1 equals. Did it turn out to where that was a 0? Yes. So I'll put that point right there at 1, 0. It is a 0, so I'll call that a 0. Is it a relative maximum or a minimum? It's a relative max also. Those are all the zeros that we see. Cool? Are there anything else besides relative extreme? Are there any other things that we could find? Isn't this like a relative min right there? So how would we find that? There's no cool way to do it besides doing second calculate. And what do you want to find out of all of these things? You want to find a minimum point, right? So it's not the minimum, but it's the minimum of the little window we're going to put it in. You got to go to the left of it, and you got to go to the right of it, and then guess, and hit equals. And ooh. A lot of us don't understand scientific notation. Depends on your calculator. Everybody's got a little bit different. It might not say that, right? It might say something else. But this really says, let me kind of write it down here. It says -5.987 times 10 to the -7th power. See this E right in there? That means you got scientific notation. Scientific notation means move the decimal. This means move the decimal 7 places to the left. So that would be -0.123456598 My calculator is not strong enough to figure out what it is really. What is that really trying to tell me that that number is? 0, right? So this point right here is at 0, -1. Your number might be different. It might be positive. It might be negative. It just depends on your calculator. Everybody's calculator is a little bit different when it comes to the amount of memory and RAM, but isn't that point at 0, -1, right there? Is that all right with you? Some of you say 0. Some of you have a different number in scientific notation. That's trying to tell you that that's 0. But it does have the E at the end, right? Okay? So let's do that. And what is that point? Let's label them. Relative max, relative min, 0. What is that? Relative min. So rel min, somewhere near it. And now the hard part. Connecting the dots. Do your best to realize that this has to go down this way. It's got to max out there and then out here. Go back around and make a rough sketch of it. That's all they're wanting us to do. Yes. Let's go for the next one. Let's type that puppy in. X to the third minus 3x squared plus 4. Think about it before you hit graph. Where's the ends going? Same way or different ways? Different ways, right? That's an odd degree. That's a cubic. Cool. And I missed something here. I need an x in there. So how about an x squared plus 4? Good. If I hit graph, it'll take me back to that same old one as before. I'm a big believer in zoom 6 in it to start it out with, to see where it's at. What's the degree of this guy? 3. What's the maximum amount of turning points it can have? If it's got degree 3, what's the maximum amount of turning points? 2. Do you see them both? Right? So that pretty much tells you that that's what the graph looks like. We good with that, or do you want to zoom it in a little bit? I like to zoom it in too. Let's go from 5s all around. Let's see what that looks like. The more you zoom in, the more accurate it is, the easier you'll learn things from it. 5s all around. Do I still see it all? I do see it all. I see those turning points, and then the end behavior we know is supposed to go other directions, right? So I see my turning points. Yeah. First, we need all the crazy points, all the zeros, all the relative extrema. I don't really care where you start. What do you say we start right there? Sound all right? Got a hunch? Do you feel that that's anywhere in particular? So I want to trace -1 it and see if that turns out to be a 0. Is that a 0? Good for me. -1, 0. Then let's label him right away. It is most definitely a 0. Is it a relative extrema at all? Nope. Next guy. Here's another supposed 0 point right here. All right, another supposed 0 point. Take a wild guess. See if that's at 2. Trace 2. Is there a 0 there? Yes. Does anybody know how many zeros are actually there? There's one with multiplicity of 2 because of the crazy, it never went below the x-axis kind of thing right there. And then this is a 0. Is it anything else besides a 0? It's a relative min, right? And there appears to be a relative max here. You know, I want to actually use the maximum function finder to do that. So that's second calculate maximum. You know, honestly, I kind of made a mistake. I wouldn't say a mistake. I made it harder on myself. If you work from left to right on the graph, on finding stuff, you never have to backtrack with your cursor or anything like that. We should have went here, and then went to here, and then went to here, and then we wouldn't have to keep going back and forth with that cursor all the time if we just worked from left to right. Where's the old max at? Again, what do you think that means right there? 0, 4, right? And then I forgot to label this guy. He's a rel max. Yep. Next guy. End behavior of him. He's a cubic. Same way or different ways? Different ways. I'm going to keep that window. I'm going to try to keep it on all the -5s, just so I don't have to change it, because maybe that's good, maybe it's not good. I can always zoom 6 it with ease. I'm just going to keep it on my, I know I'm 5s all around, so if I hit graph, again, it's a cubic, right? 3rd degree, meaning the maximum amount of turning points you'll see is 2. I see them both. Doesn't mean there will be 2, but the maximum is 2. There are 2, so that means that's it. That's a good graph right there, baby. That's a good graph. Nice. Zeros. Uh-oh. This guy doesn't look like he falls on an integer. So I can't do my cool trace like 1 trick or trace 2 trick or anything like that. I need to actually calculate where that's at. Don't we have the other y = 0 graph for our other line? So I'm going to just go straight to second, calculate intersection. First curve, just hit enter. Second curve, just hit enter. Move that cursor over close to where you feel the 0 is and hit enter. And nasty place. How do they tell us to round it in the old instructions? To the nearest tenth. So I will just kind of rough put that at -1.50. And then I'll let you find those other two places. That is a 0. Don't forget to label it. So pause the video. Why don't you find me the relative extrema, and then we'll go from there. Someone asked if we should find the y-intercept. We do not need to find the y-intercept. All we're finding is zeros and relative extrema, like rel max, rel min. So no y-intercepts needed. So should it look like so for all you in video land? You got a relative max at negative 0.7, 3.4 approximately, so we should put our squiggles out there. And a relative min here at about negative 0.7, 0.6. I didn't write the point there. And then connect them together. I'll let you try the entire next one on your own. Pause the video. Get number 4 done for me. Think about the end behavior before you punch them in. I'm going to guess that this guy is a 0, this negative 1. So if I hit trace negative 1, did I get that to be a 0? No, it turned out to be 0.5. So that means that negative 1 is not a 0. You got to do the calculation tricks. Kind of look like it, but that's why you want to zoom in also, because the closer you get, the easier it is to see if that's really a nice, neat 0 or not. So I'll let you keep going, video people. Should look like this when you're all done. 4 zeros, negative 2.6, negative 1.1, 1.1, 2.6, all approximate. 3 turning points, because this is a 4th degree, it will have a maximum of 3 turning points, which this one did have all 3 of them. The turning points are all of your relative extrema added together. It's your relative mins plus your relative maxes, so that's 3. There was 1 relative max and 2 relative mins. Did you notice anything? See this point right here? And we'll talk about that another day. But I don't want you to assume things too soon. It has to be irrational numbers or imaginary numbers. They're always in pairs like that. Are we cool with this? Finally, just a rough sketch. Make me 2 axes, normal. They ask us to sketch a possible graph that would fit this criteria. We could have different answers on this. There's no way to do it, but we need to meet all the criteria. They say on 5, it wants to be an odd-powered function. So here's basic criteria that has to happen. Odd-powered function. Where are the ends going? Same direction or different directions? They're going to go different, right? If the first one starts going up, the other one's got to end going down. And they say we need zeros at these particular places, right? So this is where it crosses the x-axis at. Let's start from left to right. Let's just put those. Negative 4. And then I'm just going to kind of make a scale out of that. Kind of messed that up a little bit there. How about putting a 1 there, dude? I'm just going to start over and put a real scale. And I know it's got to get up to negative 4. And it's got to get up to 6. So negative 4, negative 3, negative 2, negative 1, 1, 2, 3, 4, 5, 6. I don't need one on the y-axis, right? Just on the x-axis, because they want to know where the zeros are. If you want to put one on the y-axis, you can, but this is a sketch. But we have to indicate where all these zeros are. So I know there's a 0 at negative 4. I'm going to put a point there. I know there's a 0 at negative 1. I'm going to put a point there. There's 1 at 1. I'm going to put a point there. There's 1 at 3 and 1 at 6. So I know that my squiggly thing that I'm going to put on here has to cross the x-axis at all of those red dots. Does that make sense so far? So it depends on where you start, right? If I start up here, all cool. It's got to cross the x-axis there. Then it should have to turn itself around, shouldn't it? So it could cross the x-axis right here. So I'm going to make him turn and go there. And then it's got to turn around again. And it's got to turn around again. And then it's got to turn around again. And now I need to figure out where I need to go. Where does this have to go if I started with this guy going this direction? It's an odd-powered function, up or down. It's got to go down towards negative infinity. There's an odd-powered function that meets all of those criteria. You could have done it a whole other way if you wanted to. The green one would have also worked. You know, it's the complete opposite of that. And there's other ways you could have done it. You could have really went high and low. And there you could have went like, well, what if I went whatever, you know, just as long as it meets those things. So try the next one, okay? Give it a shot. Think about end behavior first. Put some zeros, you know, like a scale on the x-axis, so you can place all your zeros where they're supposed to go. Video. When they say minimum, they're making a sort of a typo. It should mean relative minimum and relative maximum. Like if they don't put the word relative, you're supposed to assume that it's like an absolute minimum, but our book is wrong. Okay? So when they say minimum and maximum, they're trying to say relative minimum, relative maximum. So here's mine. I'm going to put a 0 at -3. Any other zeros that I know about? They don't tell me about anything else. I need a minimum at x equals 4. That means low, right? So here's x equals 4. I'm just going to go down there and put some sort of dot, right? There's going to be a minimum there. I also need a maximum at -1. See if you can put a dot somewhere. That would help you there. What do you think about that? That'd be all right? Maximum, up there somewhere. Sound okay so far? That's it, except for the fact I need to make the sketch, and I got to make both ends go which way? The same way. They don't have to go up necessarily. If they would have said a positive leading coefficient, then you'd have to make them go up, but you can make them both go down. They just have to both go the same way. So I'll start with this guy. And this is supposed to be a 0, correct? So try it. You got to get from here to here somehow. And this is a 0. Could you do this? Would that work? Just a rough sketch. What do you think? Was that okay? That's fine. Could you do this? Swing and a miss. My bad. Twice. I hit that, okay? Could you do that? A lot of people say, well, wait a minute. I don't know if you can do that. What do you think? There is another 0 introduced when you do that. You know, doesn't that thing cross the x-axis again? But that's okay. You can do that if you want to. Like it has to happen somewhere in this place. There has to be another 0 because don't we have to go from here to here somehow, right? You have to cross the x-axis again somehow, which way or another. So just because they didn't tell you there's a 0 there doesn't mean that there can't be a 0 there. So whatever you want. You know, I just know that's got to max out. This has to minimize out. And then are both of my ends going the same way? This is a relative min. This is a relative max, right? And this is a 0. And of course, there are other zeros. You could even have more zeros if you wanted to. It's just, did you meet the requirements of what this says? Yes, you did. Nice.